time I started discuss this topic on Tuesday. What is a nuclear reaction? Acha students, I am trying to arrange your extra class on Sunday because yesterday I missed the class. All right, so inshallah that missed class I will take on Sunday. Okay, Sunday at 6 o'clock PST. All right, students. So now, students, what I was discussing last time, I was discussing this chapter, this topic, what is a nuclear reaction? What is a nuclear reaction? So any reaction that cause a change in the nucleus of an atom is a nuclear reaction. All right. And how many types of nuclear reactions are there? There are three types of nuclear reaction. Number one is radioactive decay, which I already discussed with you, students. All right, next is fission reaction and then fusion reaction. Fission I already discussed with you. All right, students. Okay. So what is fission reaction? As I explain you, student, fission reaction. In fission, a heavy unstable nucleus is split into two smaller nuclei just by interaction of one neutron. When one neutron is in making contact with the one nucleus, which is highly unstable, so that nucleus is split into two lighter nuclei. This phenomena is called as fission reaction. This phenomena is basically defined as fission reaction. In this reaction, we can say splitting of larger nuclei into two smaller nuclei with a release of high amount of energy. All right. So that is called fission reaction. Okay. And what about fusion? In fusion reactions, you can see two lighter nuclei are fused together to form one heavy nucleus. So fusion reactions are endothermic as well, and these are exothermic as well. Uh, what answer, Umaima? What are you talking about? I'm not getting. In fusion reaction, two lighter nuclei are fused together to form a heavy nucleus. In fusion, students, two lighter nuclei are forcefully fused together because they both are hydrogen nuclei, and hydrogen nucleus has positive charge. Hydrogen nucleus has positive charge, students. So it is difficult to fuse two positive charges because of a strong force of repulsion between them. So there is a strong force of repulsion between two charges. So it means we have to supply heat energy to fuse these two nuclei. And once they have fused, they will form a heavy nucleus, which is helium. All right, they will form a heavy nucleus, which is helium, with a release of high amount of energy. So we can say fusion is a endothermic reaction as well, and fusion is a exothermic reaction as well. All right. Acha, what I explain you, beta, that in fission is used to perform the chain reaction. Fission is used to produce electricity, and fission reactions are used for bomb making as well. But fusion reactions are only occur at the surface of a star. Okay, reactions only occur at the surface of stars. Basically, stars are light up just because of the fusion reaction. Okay, stars are light up just because of the fusion reaction. Okay, when the star will form, so it means that this star is a ball of gas and dust particle. So this star is light up just because of the fusion reaction. Clear, students? All right. So now, student, then I discuss with you the topic of fission and fusion with you in detail. You can see in the fission product, in the fission, the two lighter nuclei, one heavy nucleus is split into a lighter nuclei, and they are talking about the heavy nucleus like uranium and plutonium. They both will undergo fission reaction, and they are used as a power source for nuclear power station. All right, gamma rays are also emitted in these types of reaction. Acha, students, beta, these fission reactions are also called chain reaction. Why they are called a chain reaction? The reason is Sarin beta, 1 minute, I will reply you. The reason is, suppose that the student, if I have 1 gram of uranium sample, so there are billions of atoms in 1 gram of uranium sample. And what we are doing, we are just making a contact of one neutron with the nucleus of uranium. We are making a contact of one neutron with one uranium nuclei. So they both will make contact with each other. This product will become highly unstable and it will decompose into two fission fragments, which is barium and krypton. And you can see 3 neutrons are released here. These 3 neutrons will make contact with further 3 nuclei with the further 3 uranium. So now the 3 nucleus will decompose into three fission fragments. All right, the first one, the second one, and the third one. All right, and you can see they are releasing the 9 neutrons. So these 9 neutrons will further make contact with the 9 nuclei. So in this thing, beta, the reaction will continue to proceed. It will not stop. So it means it is difficult to stop such type of fission reactions. It is difficult to stop such type of fission reactions because once they have disturbed and once they have uncontrolled, so they will continue perform the reaction and they will produce a high amount of energy. So I told you, beta, we can control the fission reactions by using neutron absorbing rod. Neutron absorbing rods are control rods which are used in the nuclear reactor. Nuclear reactor basically we use in nuclear power station where we can produce electricity. All right, we can generate electricity, students. We can generate electricity by using uranium, plutonium, or by using the fission reaction. Fission reactions are powerful reactions to produce electricity, students. So what we are doing, these are the reactors in which nuclear reaction will occur. We will use uranium and plutonium and we will react the uranium with 1 neutron so the reaction will start. These rods, you can see, students, these rods are neutron absorbing rod. When these rods are lifted higher, so the reaction will occur at the bottom of the reactor and it will produce high energy. And this energy is used to produce electricity. But if we want to stop the reaction, if we want to slow down the reaction, so what we will do, students, we will lower these rods in the reactor. So these rods are made up of carbon. They will absorb the neutrons which are released in the fission reactions. And these absorbing neutron rods will stop the reaction, or we can say it will slow down the reaction, because neutron is a particle which is triggering the reaction. If we will stop these neutrons, you can see if we will stop these neutrons which are released in the reaction, so it will not continue the reaction. So we can stop the fission reaction here. But what I told you about fusion, student, that fusion reactions cannot occur on Earth. Fusion reactions are the source of star. Fusion reactions occur in the core of star, students. All right. So now you can write heading in your register, nuclear fusion. Nuclear fusion. All right. In fusion, two lighter nuclei are fused together to form helium, to form a heavy nucleus. And remember, beta, this question can be asked in your exam, that why high amount of heat energy is required to start the fusion reaction. So I told you, beta, in these reaction, we are fusing the two lighter nuclei. You can see here, deuterium is a nucleus of hydrogen isotope. Tritium is also the nucleus of hydrogen isotope. These two nuclei will be fused together to form helium. But obviously, two positive nuclei cannot fuse easily because they have same charge. And due to the same charge, there is a strong force of repulsion. Strong force of repulsion. So we have to overcome this force of repulsion, students. And how we will overcome? We have to supply heat energy to this system. We will supply heat energy. Obviously, we cannot, stars will supply heat energy to the hydrogen nuclei. So they will fuse together to form helium, heavy nucleus, and it will release the energy which is quite greater. So it means, beta, fusion reactions are only occur at the surface of stars, and it requires energy as well, and it produces energy as well. All right. Acha, Sarim, you were asking question. Endo gives out of energy. Endothermic means the system require energy to perform the reaction. Like the energy required to start this fusion reaction, that's why it is endothermic, or it is releasing the energy, so it means exothermic. Okay. If the system is releasing energy, it is exothermic. If the system is absorbing energy, Sarim, it is endothermic. Okay. Hafsa, in definition of fusion is two lighter nuclei will fuse together to form a heavy nucleus. That is the fusion reaction. When two lighter nuclei join to form a heavy nucleus. Clear, students? Nuclear fusion has proven very hard to reproduce on Earth. So this is the same thing, beta, which I discussed with you. Stars use nuclear fusion to produce energy, obviously. Obviously, beta, star use nuclear fusion to produce energy. All right. Obviously, the star is light up just because of the nuclear fusion. All right. And the stars have different color just because of these reactions. Because some reactions are more powerful, they are releasing high temperature. And some reactions are less powerful, so they are releasing less temperature. So because of the temperature variations, every star has different color. Okay, just because of its surface temperature difference. Acha, Sarim, what you are asking, what does it mean by maintain? देखिए बेटा, they are saying this process require extremely high temperature to maintain, means to start the reaction. To start the fusion reaction, it requires high temperature. So that's why we say it's an endothermic reaction. Because if the star is not heat up, if the star is not rotating on its axis, so the temperature is not high. If the temperature is not high, so the star will not start the fusion reaction. Okay, star will not start the fusion reaction because the temperature is not high enough. Clear? Any question here, students? Arshman, we have started, we are going to end the chapter radioactivity, all right?
Okay, ma'am.
All right. Okay, so now students, you can see there are some equations which are showing nuclear fusion reactions. So every reaction is different, but in each and every reaction, you can see two lighter nuclei are fusing together to form a heavy nucleus. You can see in the first equation, these are the two isotopes of hydrogen. Both are deuterium, and they are forming the helium isotope with a release of one neutron. But if you will see the last reaction in which two lighter nuclei, one hydrogen and one helium isotope is fusing and it is forming a helium. And this helium is massive than this helium nuclei and it is releasing 18.3 mega electron volt energy. So it means, beta, every reaction is releasing different energy. So that's why the star surface temperature is different. Every star has different temperature. All right. No, Hafsa, you don't need to memorize these equations. You don't need to memorize these equations, all right? Now, this is one of the famous equation of Einstein, that is E is equals to mc square. According to this equation, energy and mass are interconvertible to each other. When mass is destroyed, energy is produced. When energy is destroyed, mass is produced. For example, students, if you are lighting up a matchstick, so you are burning the wood stick due to which light energy is produced. So it means you are destroying the mass and creating the energy. So mass is converted into energy. Similarly, beta, when the universe was in the origin of the universe, there was a big explosion, and due to this explosion, there was explosion of energy. Mass was created. This explosion is called supernova explosion. And due to this explosion, beta, universe was formed, galaxies were formed, different planets were formed. So it means, according to this Einstein equation, energy and mass are interconvertible. Our entire universe is made up of either mass, means matter, or either energy. All right. So the universe exists in form of either energy or matter. अगर मैं आपको इसकी पाई डायग्राम बना के दिखाऊं तो साइंटिस्ट ये कहते हैं कि वी हैव ओनली डिस्कवर्ड द 4% ऑफ यूनिवर्स मैटर एंड रिमेनिंग 96% एग्जिस्ट इन फॉर्म ऑफ एनर्जी. क्लियर? अच्छा, व्हाई वी आर यूजिंग दिस इक्वेशन हियर, E equals to mc square. Why we are using here, students? Look at this equation. Look at this equation, beta. This is a fusion reaction because you can see two lighter nuclei are fusing together. So this is the AMU mass of hydrogen at isotope deuterium. This is 2.013553 and the isotope, another isotope of hydrogen is tritium. If I will add both masses in AMU stands for atomic mass unit. It's a smaller unit, beta. So we are getting this total mass of these input products. But at the output, if I will calculate the mass of helium and neutron, and by adding both of them, I'm getting this mass. So it means we are getting less mass at the output as compared to input. I'm repeating, students, we are getting the less mass at the output as compared to input. So where this mass will vanish? Where this mass is? देखिए, मास को हम डिस्ट्रॉय कर रहे हैं तो ऑब्वियसली इट विल बी कन्वर्टेड इनटू एनर्जी. ऐसा तो नहीं है ना एकदम गायब हो जाएगा. ठीक है, तो इट मींस इफ आई सबट्रैक्ट बोथ वैल्यूज, सो आई एम गेटिंग द मास डिफरेंस 0.019431. दिस मास डिफरेंस इज कॉल्ड मास डिफेक्ट. Mass defect, it means this mass will be converted into the energy. So that's why we are releasing the sun is producing the energy at the output, because some mass of sun is converting into the energy. आपको पता है सन एक सेकेंड में बिलियंस ऑफ टन्स ऑफ हाइड्रोजन फ्यूल को जो है वो खर्च कर रहा है, और उससे हमें क्या प्रोड्यूस हो रही है? एनर्जी. बिलियंस ऑफ टन्स ऑफ हाइड्रोजन इज यूजिंग एट एवरी सेकेंड. दैट्स व्हाई द सन इज प्रोड्यूसिंग एनर्जी. ऑल राइट. So it means the mass is converting itself into energy. All right. And we can this mass is given in kg, and we can calculate the energy by using this equation. E equals to mc square. M is the mass difference. C is the speed of light. Obviously, the energy released on the sun is in terms of speed of light. देखिए, speed of light जब मैं कहती हूँ तो हमारे जहन में परसेप्शन आता है लाइट की स्पीड. तो लाइट की स्पीड में सब कुछ आ जाता है, रेडियो, माइक्रो, इंफ्रा, ऑल रेडिएशन, थर्मल रेडिएशन एज वेल, हीट रेडिएशन एज वेल. जिस स्पीड से लाइट एनर्जी हम तक पहुंच रही है उसी स्पीड से हीट एनर्जी भी पहुंच रही है. ठीक है, तो सी इज द स्पीड ऑफ लाइट. Speed of light. Yes, you have to write this equation. E is equals to mc squared. E is equals to mc squared. Now, students, let's have a look on the past paper question. You can see question number 23. In this question, they are saying which row is correct for nuclear fission and nuclear fusion. So, fission means a large nuclei is broken into two smaller nuclei. So, two smaller nuclei is produced. So, answer can be C or answer can be D. In fusion, two lighter nuclei are fused together to form heavy nucleus, and the fusion is the only source of star. Well done, everyone. C is the correct answer. Okay, C is the right answer. Now look at the next question. Question number 30. In 30, they are saying in nuclear dash, hydrogen nuclei dash to form helium nuclei releasing energy. Which words correctly complete gap 1 and gap 2? Sarim, check your answer, beta. Well done, Arshman. So, in nuclear fusion, hydrogen, if they are talking about hydrogen, so only the hydrogen can perform the fusion reaction. They cannot perform fission. So, answer can be C or answer can be D. So, hydrogen nuclei will join together. Hydrogen तो खुद इतना smaller atom है. हमारी entire universe, 90% universe हमारी hydrogen से बनी हुई है. ठीक है, because it is the smallest atom, it is the lightest element. The entire universe is made up of hydrogen. All stars are made up of hydrogen. Okay, so it means beta these in fusion reaction two lighter nuclei will join together. अब hydrogen मजीद थोड़ी split हो सकता है किसी में. ये तो खुद सबसे स्मॉलेस्ट एटम है पूरे पीरियोडिक टेबल में. अच्छा, नाउ लुक एट द क्वेश्चन नंबर 53 स्टूडेंट्स. In question number 53, they are saying which equations shows a nuclear fission? Sarem, they are talking about fission. Fission means a large nuclei is splitted into two lighter nuclei. Heather, are you sure B is the right answer? Sarem, Heather, why you are giving me incorrect answer, beta? They are talking about fission reaction. Fission, only uranium and plutonium can perform the fission reaction in which an unstable nuclei of uranium is split into two lighter nuclei. So one lighter nuclei is strontium, the other lighter nuclei is xenon, and it will release 3 neutrons. So this is the fission reaction, students. ये फिजन है, यहाँ पे तो फ्यूजन हो रहा है, ठीक है. So D is the right answer. Okay, well done, students. D is the correct answer. Now look at the next question. In a fission reactor, which particle causes the uranium nucleus to split? So how the uranium fission reaction will proceed, beta? Exactly, students. Well done. Heather good. Sarim good. Inaya. Fission reaction can start with a process of neutron. Only we required one neutron to start the reaction. And once it will start it is difficult to control, beta. Only the neutron absorbing rod can control these reactions. Now look at this question, beta. I have taken from theory paper. I will send you the theory past papers as well, students. So you can solve the questions related to fission and fusion. So you can see question number 8. They have given us the equation in which two lighter nuclei, proton and neutron, are fusing together to form helium. They are saying state the name of this type of reaction. So obviously this is a fusion reaction because in fusion two lighter nuclei will fuse together. Well done, students. Well done. Now in part B, they are saying the speed of light is 3 into 10 raised to power 8 meter per second. The mass of the helium nuclei produced is different from the total mass of 2 protons and 2 neutrons. Obviously, the output product mass will be different than the reactant masses because there is a mass defect. Some mass will be converted into the energy. All right, they are saying explain why energy is released during this reaction. So you can write here, beta, that in this fusion reaction, mass will be converted into the energy according to this formula. E is equals to mc square. E equals to mc square. Mass is converted into energy. आपको पता है अगर कोई मास लाइट की स्क्वायर स्पीड से ट्रेवल करेगा तो उसका मतलब वो मास नहीं रहेगा, वो एनर्जी में कन्वर्ट हो जाएगा. अगर ह्यूमन बॉडी भी लाइट की स्क्वायर स्पीड से ट्रेवल कर सके, ये तो वैसे तो ये पॉसिबल नहीं है ऑब्वियसली, बट इफ वी विल ट्रेवल विद द स्क्वायर स्पीड ऑफ लाइट, सो वी कैन ट्रेवल इन पास्ट, we can travel in present, or we can travel in future as well, because we will no longer be a matter, we will be converted into energy. Is it interesting thing, students? All right. So if a matter is moving with the square speed of light, it will be converted into energy. So this is the famous energy equation of Einstein. Now look at the next part, student. In this next part, you can see this question has 3 marks weightage. In this question, they are saying calculate the energy released in the reaction. Calculate the energy released in the reaction. Mass is given, light speed is given. Just we have to use this formula, students, E equals to mc square to calculate the energy. It's very easy. Just you have to put the values in the formula. Mass is 6.6 into 10 raised to power minus 29. Light speed is 3 into 10 raised to power 8 whole square. So we have to put the values on the calculator, beta, simplify it and we will get the answer. 3 exponential 8 whole square multiply by 6.6 exponential minus 29. So what we are getting? Well done, Sarim. We are getting the energy 5.94 into 10 raised to power minus 12 joule. This energy is produced during only one reaction. Only one reaction. And I told you, beta, the billions of hydrogen is lost in 1 second from the sun. Students, are you understanding this topic? It's very easy. Acha, only from this chapter, one topic is remaining, that is Wilson cloud chamber. Actually, I didn't add the picture here of Wilson cloud chamber. So, students, inshallah, as I told you, beta, कि I will take your extra class on Sunday at 6 o'clock PST. I will announce on the group as well, because yesterday I didn't take class due to some issue, beta. So that's why I will adjust your class on Sunday at 6 o'clock PST. So in that class, we will discuss Wilson cloud chamber. Okay. Wilson cloud chamber. All right, students. All right. So students, now we have completed this chapter of radioactivity. It was very easy, easier than magnetism. So now we are moving towards the last section, that is space physics. Space physics is very easy, beta. Hardly it will take few days to complete this space physics chapter, because they are very easy and most of us know the basic knowledge. Yes, obviously, formation of stars are the part of our syllabus. All right, formation of a star, life cycle of a star, how the massive star is converted into a black hole, neutron stars, they all are the part of the space physics syllabus. From radioactivity, Heather. Heather, we have already done many questions of radioactivity. For radioactivity question, beta, I will send you these files. You can see here, beta, I will send you these files of topical theory past papers of radioactivity. 1 minute. So these are the list of files I have. I will share 3 files with you. So you have to do a practice of these files as the homework. And if you are not understanding any question, so you can tell me on the WhatsApp group. So we will discuss that question on Sunday class. Okay. Okay, students. So now, students, I am moving towards the new topic, that is space physics, solar system. Basically, there are 3 chapters of space physics: solar system, the earth, the universe. The earth is a very easy chapter and it is little bit boring. So that's why I'm starting from the solar system. All right. So students, you can write the heading in your register: solar system. Solar is the name of our sun, and lunar is the name of our moon. Moon name is lunar, sun name is solar. All right. Solar system. So it means that our sun has a family, a system in which there are many beta objects, like the 8 planets are revolving around the sun. There are natural and artificial satellites, dwarf planets, asteroids, comets, meteoroids. So these all are making our solar system. And solar system is the only habitable zone. Beta, we will study Earth in the last. We will study the chapter Earth in the last. Solar system is a little great, it's interesting chapter. So I started this chapter first. Okay. We will study Earth chapter in the last. Okay. So what are the components of our solar system? The sun, 8 planets, natural and artificial satellites, dwarf planets, asteroids, and comet. So sun is a massive ball, students, which is at the center. Sun is a giant ball. Acha, sun is not terrestrial, beta. Sun is not terrestrial. Sun is a gas giant ball which is present at the center. Okay, Gasharib and Sarim. All right. So sun is the giant ball which is at the center, and all the planets are revolving around the sun. Sun is performing rotational motion as well and orbital motion as well. Can anybody tell me what is the difference between orbital motion and rotational motion?
11. Me.
What is the difference between orbital motion and rotational motion? Students, Sarim? Can anybody tell me, Vanya, what is the difference between orbital motion and rotational motion? Inaya is saying orbital motion is just imaginary. Sarem is saying a curve orbit. Orbital motion is revolution around sun. Well done, Arshman. Heather is saying orbit is around the sun and rotation is on its own axis. Well done, Heather. देखिए बेटा, orbital motion means that the object is performing a motion in a complete circular orbit around any massive object. Like all the planets are rotating around the sun, moon is rotating around the planet, and sun is also rotating around the galaxy as well. And you know, all the galaxies are rotating around a massive constellation which is called quasars, quasi-stellar stars. So it means, beta, orbital motion means like all the planets are performing rotation around the sun. All the planets are moving around the sun. That is called orbital motion. So sun is also performing the orbital motion. Sun is making one complete revolution around the galaxy, and it will take 1 lakh light years to complete one revolution around a galaxy. And sun is moving at its own axis as well. Like the fan is rotating on its axis, earth is rotating on its axis. So that's why the day and night will form. Similarly, beta, sun is rotating on its axis as well. So that's why sun has its own gravity. Every rotational object will have gravity. Asteroids has no gravity. Why? Because asteroids are not rotating on its axis. So that's why the gravity of asteroid is 0. But sun is rotating on its axis. All the stars are rotating on its axis. So they have their certain gravity. All right. So sun is our solar system 99% mass is made is basically consist of sun. अगर आप solar system को compare करें students atom के structure से, तो do you remember the which experiment I explained you, Rutherford experiment? In Rutherford experiment, I told you the all the mass of atom lie in the center, that is nucleus. Similarly, beta, all the mass of solar system lie at the center, which is sun. Sun is a giant massive ball. We are tiny dot in front of the sun. If I compare the earth with the sun, so you can see the earth is a small tiny dot. And sun is a massive hyper body which is rotating on its axis. All right. And students, there are very similarities between the atomic structure and the solar system as well. Like if I talk about the orbits of the atom, so initial orbits of atom are very close, and similarly, beta, initial orbits of inner planets. Inner planets are Mercury, Venus, Earth, and Mars. So you can see all 4 planets are very close to the sun, and outer planets are Jupiter, Saturn, Uranus, and Neptune. They are very far away from the sun. All right. So there are many similarities between solar system and atom. Are you understanding this, students? So there are 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So how many planets you have located, students? How many planets you have seen? All 8 planets. सारे देखे हुए. I'm talking about on the sky, with the naked eye. How many planets you have seen, beta? Like I have located this planet Venus, Mars, Jupiter, Saturn, Uranus, and Mercury as well. I never saw the Neptune. All right. So we can see all these 7 planets with the naked eye. If you know the constellation where it can lie, if you know the season, I can share the I can share the pictures with you on the WhatsApp. Almost I have located all the planets. The brightest planet which we can see on the night sky is Venus. Venus, all right. Venus is the most brightest planet which we can see. It looks like a bulb which is light up in the sky. All right. So Venus is the brightest and a very beautiful planet. Okay, well done, Umaima. So you can see, students, these 4 planets, Mercury, Venus, Earth, Mars, are called inner planets. They all are terrestrial. They all have a land, surface, rocks, and there is a belt which is called asteroid belt, which is lying between Mars and Jupiter. So this is the asteroid belt in which there are billions of asteroids which are rotating around the sun. All right. And after this asteroid belt, there is one planet that is called Jupiter. Jupiter is very massive. Jupiter is very massive. Students, 2100 Earth can fit inside this Jupiter. Can you imagine? 2100 Earth can fit inside a Jupiter. Jupiter को कहा जाता है it's a mother planet. As the mother protect their child, similarly Jupiter is protecting the planet Earth because it is attracting all the asteroids towards itself. So that's why only few asteroids will fall on the surface of Earth. So that's why it is behaving as a mother planet, and it is balancing the force of gravity on our planet as well. Yes, okay, Naya. All right. So now, students, all four planets which are lying outside the asteroid belt, they are called outer planets and they all are gas giant. Yes, Sarim, Jupiter is visible. They all are gas giant. Students, Jupiter, Saturn, Uranus, Neptune, they are not terrestrial, they are gas giant. All right, they all are gas giant. Pluto is a dwarf planet, Umaima. Pluto is a dwarf planet. It is not lying in the category of planet because of its small size. Although Pluto has 5 moon, Pluto के भी अपने moon है 5, ठीक है? But Pluto has a very small size, and due to the its characteristics, it is considered as a dwarf planet. All right. Beta, Pluto is a dwarf planet, so that's why we usually discuss all these 8 planets RM in our books. Pluto is considered as a dwarf planet. There are 5 dwarf planets in our solar system. All right, there are 5 dwarf planets. Dwarf planets are those planets which are not lying in the characteristics of main planet. Okay, Mania, Ishal, are you here in the class? Acha. Now, students, what are natural and artificial satellites? Can anybody tell me the difference between natural and artificial satellite? Vanya, are you in class?
Yes, miss.
Okay, moon is a natural satellite. Obviously, all the moons which are lying in our solar system, they all are natural satellite. All right, and what about the artificial satellite? Artificial satellites are man-made satellite like the NASA launch ISS. ISS is International Space Station. All right, ISS is International Space Station. It's our biggest satellite which the NASA has ever launched. All right, so these satellites are man-made. Exactly. So, acha, what is the difference between asteroids and comets, student? What is the difference between asteroid and comet? Comets are the part of our solar system. Have you ever seen the comet? Any comet, students? No. Okay. Exactly. Well done, Arshman. Asteroids are rocky. Asteroids are rocky. They are made up of different minerals. They are made up of different materials as well. There are some asteroids, beta, which are very expensive. They are made up of those materials which are very precious, which are very expensive. But if I talk about the comet are made up of gas and dust, and they have long tail which is made up of ice. Comet are not the part of our solar system, students. Comet will can enter outside the interstellar space. We can say comet will